Hello and welcome to another exam paper walkthrough. Today we're doing a slightly different set of papers. Today we're doing the Edexcel aiming for grade 5. And I'm going to be looking at paper 1 today, so the non-calculator version. In the description to the video you will find a link to a Google Drive where you can access a copy of this paper. I would strongly recommend you download and either do it alongside or do it before watching the video. But either way it will be useful revision. I would strongly recommend you get some music on in the background. I tend to have some on while recording these videos. It helps me get through them. And please subscribe if you like. Okay then, so question 1, write 124 as a product of its prime factors. So I will always break this down with the factor tree, and I always take off the lowest prime number, so 2 in this case. So that's going to be 2 and 62, which is going to be 2 and 31. So I've got my prime factors. So that's not quite it though, I need to write it as a product of its prime factors, so 2 times 2 times 31. Okay, question 2 then. So find the value of y. So y is going to be equal to 360 minus 70. So that's going to be 290 degrees. And part B says give a reason for your answer. And it would be angles at a point equal 360 degrees. Okay, and question 3. So a storage tank exerts 10,000 newtons on the ground. The base of the tank is in contact with the ground is 4 meters by 2 meters. Calculate the pressure on the ground due to the tank. Okay, so we've got the formula here. Pressure is equal to force, which we're told is 10,000, divided by the area, which is going to be 4 times by 2. Okay, we could do this multiplication, but I think it's going to be easier if we actually do this division. Break it up slightly. So I'm going to do 10,000 divided by 4 and then divide by 2. So 10,000 divided by 4 is going to be 2,500, and then divide that by 2 is going to be 1,250. And then just checking my units, we've got newtons and meters. So the pressure should be in Newton meters, and it is. So 1,250. Okay then, question 4. So Savio leaves home at 7:30 to drive to work. He drives a distance of 50 miles. Savio thinks he drives at an average speed of 40 miles per hour. If Savio is correct, what time will he arrive at work? Okay, so we are looking at travelling, speed is equal to distance divided by time. What time? So time is going to be equal to speed divided by speed. So in this case, we've got a distance of 40 and a distance of 50 and a speed of 40. So that's going to be 1¼ hours. So if we say he starts at 7:30 and we want to add on 1 hour and 15 minutes, he's going to arrive to work at 8:45, or in the same format, 08:45. In fact, his speed is greater than that. How does that affect your answer to part A? So we'd be dividing by a larger number, so we'd get a smaller number here, so it would take less time. It would take less time, or he would arrive earlier. Would less time, so he would arrive earlier. Okay, and question 5. Solve. We've got solve an inequality. I'm going to treat it just like an equation. So I'm going to start by adding 27 to both sides. That will give me 7x is less than 35. Divide both sides by 7. And I get x has to be less than 5. So x is less than 5. Okay, question 6. There are 240 cans of drinks on a shelf. Each can contains cola, lemonade, or orange. The number of cans of cola to the number of cans of lemonade. The number of cans of orange is 5 to 3 to 2. A half of the cans of lemonade and 1/12 of the cans of orange are removed from the shelf. Work out the number of cans of cola as a percentage of the total number of cans of drink remaining on the shelf. Cognitive overload of this question is just immense. There's just a lot to take in. So what I'm going to do to just make that simpler for myself is to just break it down into things that I can visualize a lot better. So if I just call the ratios C, L, and O, C, L, and O, and I'm going to go 5 to 3 to 2. So I've used that bit of information, and I've just, in effect, simplified that whole statement. There are 240 cans of drink on the shelf, so the total of these ratios is going to be 240. We're told then that half of the orange are removed, so I'm going to just put another line in of removed, half, and 1/12 of the orange, 1/12 are removed. Work out the percentage. So I'm going to start to try and now I'm going to start to do a bit of maths on this. So the first thing that I'm going to do is I'm going to just make this a bit simpler for myself. There are other ways you could do this. I'm just going to try and make this simpler for myself. I can't take away 1/12 from this ratio yet. So I'm going to make it a bit simpler for myself, and I'm going to make it a ratio over 12. So if I times that by 6, that would be 12. If I times this by 6, that would be 18. And if I times this by 6, it would be 30. So that is the same ratio. It's just what I've done is make the numbers simpler for me to take a 1/12 away and a half away. So if I say, if I've taken a half of the cola cans, I've now got a ratio of 15 to 18, and I've taken a 1/12 away to 11. I'm thinking I don't actually need this 240. Now it says, work out the number of cans as a percentage of the total. So I don't think I really need that. If I look, now my ratio has got 15 plus 19 plus 11. So my ratio has got, and I might come back and alter this method shortly. I've made a mistake, haven't I? So Alfonso, you spotted the mistake. It's just in my reading. Where's my mistake? So my mistake here is I've halved the cola cans. I'm supposed to be halving the lemonade cans. So what I've actually done is fine up to this point, but that should be 30 and that should be 9. So now my parts of my ratio, I've got 30 plus 9 plus 11, so I've got 50. If I'm expressing the cola as a ratio of the total, that's going to be 30 out of 50, which is going to be 60%. That question did lead you to, we didn't actually need that 240, we could have done it just with the ratios. That's kind of a bit of a shorter way of doing it. Right, for question 7, work out 0.04 times by 0.32. I tend to use a very straightforward method for decimal multiplication, which I would just treat it as numbers. So I treat it as 4 times by 32. So 4 times by 32 is going to give me the digits of 128. So my digit value for this is going to be 128. But in my question, I've got 1, 2, 3, 4, 5 decimal points. So in effect, I need 5 in my answer. So it's going to be 0.1, 2, 3, 4, 5. That's an absolutely fine way of doing it. It will tend to, well, it will always work. My issue is it's not overly clear. So I will go through a longer version of that just to explain why that works. If I imagine that these numbers were in standard form, that would become 4 times 10 to the minus 3. If I imagine this number was in standard form, and I'm still timesing them, it would be 3.2 times 10 to the minus 2. If I multiply those digits together, I would get 12.8 times by 10 to the minus 5. And then if I converted that into a normal number, I need my decimal point to move. I feel like I've made a mistake. 1, 2, 3. No, there we go. That was only a 1. So that should have been a 4. And then if I convert that into a normal number, that would become 0.00125. But I don't tend to do it in standard form. I tend to do it as normal digits, do the multiplication, and then look at the decimal placement. So 0.00125. Okay, and next question. Jenny drives from London to Swindon at an average speed of 54 miles per hour. She drives for 1.5 hours. Work out the distance from London to Swindon. So distance is going to be equal to, well, speed is equal to distance divided by time. So distance is going to be equal to speed times by time. So I'm going to say I'm doing 54 times by 1.5. So 54 times by 1 is 54. 54 times by 0.5 is going to be 27. So I'm looking at 54 plus 27, which is going to give me 181. And then Alexi is using a map. The scale of the map is 1 to 25,000. On the map, a road has a length of 6 centimetres. Work out the length in kilometres. If I start with the actual conversion, 1 to 25,000, that means that 1 centimetre on the map would equal 25,000 centimetres in real life. There are 100 centimetres in a metre. So I can cross 2 zeros off. So 1 centimetre on the map would equal 250 meters in real life. There are 1,000 meters in 1 kilometre. So in effect, 1 centimetre on the map is going to equal 0.25 kilometres in real life. So 6 centimetres is going to be equal to 25, well, that's going to be 1.5 kilometres. Okay, so question 9. Write 1.63 as an ordinary number, times 10 to the minus 3 as an ordinary number. I tend to view this minus 3 as I'm going to add 3 zeros at the start. So that's just going to be 0.0030, 163. And then if I want to write this number in standard form, I need to place a decimal point to make it somewhere between 1 and 10. So I'll place it between the 4 and the 3. So my number part becomes 4.38 times by 10 to that. And then I've moved the decimal from there. So I've moved it a total of 1, 2, 3, 4, 5 places. So it would be times 10 to the 5. And part C, work out the value of 4 times 10 to the 3 times by 6 times 10 to the minus 5. So giving your answer in standard form. So I break this into 2 parts. The number part, which is going to be 4 times 6. And then the index part, which would be 10 to the power 3 times by 10 to the power minus 5. So 4 times by 6 is going to give me 24. And then my indice part, 10 to the 3 times 10 to the minus 5 becomes 10 to the minus 2. And then I need to rearrange, so I need to readjust. So I'm going to add 1 to the power. So it's going to become 2.4 times by 10 to the, and then minus 2 plus 1 becomes minus 1. So 2.4 times 10 to the minus 1. Okay. Question 10. At the end of October, Fiona's electric bill read that. At the end of November, her electricity meter read that. Each kilowatt of electricity costs 16 pence. Work out how much Fiona had to pay for the electricity used in November. Okay, so the first thing I need to do is subtract these numbers, so it's working on a very basic subtraction, but giving us quite complicated numbers to do it with, or numbers that look complicated to start with. So I'm just subtracting those. 8 take away 8 is 0, 9 take away 3 is 6, 1 take away 6 I can't do, so I need to take one from here. So that's 4, and then 0, 0. So 460. I then need to do 460 times by 16. So 6 times by 0 is 0, 6 times by 6 is 36, 6 times by 4 is 24, plus the 3 is 27. Then 2 zeros need to be added now because I'm multiplying by 10. So 1 times 0 is that 0 there. 1 times 6 is 6, and 1 times 4 is 4. I then add those two numbers together. So 0 plus 0 is 0, 6 plus 0 is 6. 7 plus 3 is 13, so carry the 1. 2 plus 4 is 6, plus the other one is 7. So that's going to be my digit value, and that's going to be in pence. Does it specify in pounds? It doesn't. So I think I could get away with that, but by convention I would convert that into pounds. So that's going to be £73.60. And I've just had a quick look. The mark scheme does accept that you can, the mark scheme states that I can accept 73.6 or 7,360. So we could have left it in pence. Okay, question 11. Find the coordinate of the midpoint P. Well, we can kind of do this one virtually by inspection. I always find finding the midpoint easiest if I kind of create that. So the midpoint is going to be directly halfway between, so in effect halfway between there and there. So that would be my midpoint. And the coordinates then of that would be minus a half, 1. So I've done that by inspection. You could have done it by finding the actual values, subtracting them, dividing them by 2. Adding them and dividing them by 2. But I think by inspection is probably easier for that one. Okay, question 12. Here are two triangles on a grid. Triangle B is an enlargement of triangle A. Write down the scale factor. So I just need to look at a dimension. This is 3 squares across. On the enlargement, it is 6 squares across. So it's been enlarged by a scale factor of 2. Mark on a grid with across the centre of enlargement. So for the centre of enlargement, the most straightforward way is to join points and extend. So if I go through those 2 points and extend, and then I also want to go through another 2, can do it for all of them, but 2 is enough. We'll do 2 and then we'll do a third to check. So like points all the way through. So there's our coordinate. So mark on it with a cross is what it actually stated. So there we go. Okay, and part B. Here are 2 parallelograms on a coordinate grid. Parallelogram D is a reflection of parallelogram C. On the grid, draw the mirror line. So we can do a similar thing if we look at like points and go directly in between them, like points directly in between them, like points go directly in between them. That becomes our line of reflection. Let's just match that with my writing colour. I'll make it a little bit thicker. There we go. Okay, write down the equation of the mirror line. So the mirror line is, well, if you look at any coordinate, the x and the y values are equal. So y is equal to x would be the equation. Although I'm sure you can get away with x is equal to y. Just okay. Right. Question 13. Work it out. So we're looking at adding mixed fractions. Again, I tend to take a shortcut with this the majority of times. I treat it as a number part and a fraction part. My number part is going to be 1 plus 2 to start with, although I might need to adjust that afterwards. And all that does is save us having to do any larger multiplication with the improper fractions. So the lowest common multiple of 5 and 4 would be 20. I would need to times this fraction by 4, so the numerator would become 12, and this numerator would become 5. So I'm looking at my number part being 3, and then my fraction part being 17 over 20. And you could have, of course, done that by converting them both into improper fractions and working it through that way, and then converting back to a mixed. I just find that slightly longer than is needed. Okay, part B, show that 2 and 2/3 divided by 6 is equal to 4 over 9. So I'm going to rewrite this slightly differently. I'm going to say that that's 2 and 2/3 divided by 6 over 1. Just because I'm more comfortable with showing how you divide by fractions, and 6 would be equal to 6 over 1. Then when I'm adding, I can take that shortcut and keep them as a number part and a fraction part. For dividing or multiplying, I can't. So I need to convert this to being an improper fraction. So 2 times by 3 is 6, plus 2 is 8. So that's 8 over 3. And then when you divide by a fraction, it has the equivalence of multiplying by the reciprocal. So, and then I always take this shortcut, which not a lot of students like to do, but it's one that I always find it easier to simplify than multiply, then simplify. So 8 and 6 have a 2 in common. So 2 goes 3 times into that and 4 times into that. So that's going to become 4 times by 1 is 4, and 3 times by 3 is 9, which is what we were asked to show. So that's how I would go about that question. And write down the value of sine 30. So always a bugbear, exact values of trig. Some people remember them. I'm terrible at remembering them. I always go from how we work them out. So I would imagine that I had an equilateral triangle that was 2 by 2 by 2. No, 1 by 1 by, yeah, 2 by 2 by 2. I drop a vertical line there, and I say that this length here would be, that's now 1. So 2 squared is 4, so that's going to be root 3. And that's going to be my 30-degree angle. So the sine ratio is sine is equal to opposite over hypotenuse. So sine of 30 is going to be equal to, let's change pen color just to show this. This is the opposite side, and this is the hypotenuse, so it's going to be 1 over 2. So some people have really good memories. I wish I did. Unfortunately, I don't. So I always have to go from the triangles. If you've got a method for remembering them, that's great. I struggle with it though, so I remember the method rather than the values. And then this is quite a nice question. In effect, it's giving you two views of a cylinder. So if we just remember cylinder, work out the volume of the cylinder. So we can work out the area of the circle, leaving your answer in terms of pi, so that just means that we leave it, we don't have to multiply by the value of pi. So the volume of the cylinder is going to be the area of the circle, which would be pi r squared, times by the height or the length of the cylinder. So if I call that my r and I call that my L, so r is going to be equal to 3, so it's going to be pi times by 3 squared times by the length, which is 2, 4, 6 times by 6. Just double checking that we've got a centimetre grid. I'm going to assume it's a centimetre grid. Yeah, it says centimetre grid there. Okay, so that's going to become 9 times by 9 times by 6, which is going to be 54 pi. Centimetres squared. There. So I've fallen for a mistake here. Anybody spot what mistake I've made? Okay, my mistake is this isn't actually the length. So this is 6 centimeters, which is actually the 6 centimeters is not this length. The 6 centimeters is this. That's the 6 centimeters. So my actual length here should have been 5. So I should have times by 5 here, not by 6. And have we got a unit? We have, so it's 45 pi. Okay then, and question 16 here is a quadrilateral. So we've got the dimensions in terms of x. All measurements are in centimeters. The perimeter is 52. Work out the length of DC. So I need to add all four sides together. So I'm going to do it in the chunks. So 2x plus x plus x plus x gives us 6x. And then my number part, minus 5 minus 1 is minus 6 plus 1. So we've just got minus 5 is equal to 52. I'm then going to add 5 on both sides. So 6x is going to be equal to 57. And then divide both sides by 6 is going to give me x is equal to 9.9 and a half. And what does it actually ask? Work out the length of DC, so that's this length here. So 2x. So actually I should have just divided by 3 here. So 2x is going to be equal to 19. Okay then. Question 17. Here is a regular hexagon and a regular pentagon. Work out the size of the angle marked with the X. You must show all your working. Okay, so I'm going to work out the exterior angle of both the shapes and then add them together. So the exterior angle of the hexagon is going to be 360 divided by 6, which would be 60 degrees. And the exterior angle of the pentagon is going to be 360 divided by 5, which is going to give me which is going to give me 5 is going to 36 fully, 7 times with 2 left over, with 1 left over, so 72. So I'm just going to add those together then. 60 plus 72 is going to give me 132. That's not the only way you could do it. That's just, in my mind, the most efficient way of doing it. Okay, question 18. Complete the table of values for x squared minus 3x plus 1. So I'm going to start with this value. I find starting with the negatives can be a little bit confusing. So when x is equal to 2, y is going to be equal to 2 squared, which would be 4 minus 6 plus 1. So that's going to be minus 1. Then I'm going to look when x is equal to 3. So y would be equal to 3 squared, which would be 9 minus 9 plus 1. So that would be 1. When x is equal to 4, y is going to be equal to 4 squared, 16, minus 3 times 4, 12, plus 1. So we're looking at 4, 5. And then in theory, if I've done this right, this one should also be 5 because we've got this pattern of symmetry. So let's look when I do it up here. When x is equal to minus 1, y would be equal to minus 1 squared would be 1. Minus 3 times minus 1 would become positive 3 plus 1. So yeah, that does equal 5. On the grid, draw the graph of from the values. So -1 and 5. I kind of like doing these just for ease in opposites. Then we've got 0 and 1 and 3 and 1. And then we've got -1 and -1. So that's going to be my crosses. I then need to draw them up with as smooth a curve as I can. I always tend to rotate, so I've just rotated my screen so that my wrist's on the inside of the curve so I can get as smooth a curve as I can. It's not particularly easy to do this on a screen, but keeping my wrist on the inside of the curve, because your wrist forms a natural curve. So that would do. And does it ask a follow-up question? Use your graph to find an estimate for the solution of. Right, let's just compare this equation to what I've been asked. The same part, so I'm just looking at where it intercepts with the line y is equal to 0. So that's the line y equals 0. Then I just need to kind of read them off, and it looks like minus 0.4 and 2.6. Let's just write that a little bit better. So x is going to be equal to 0.4, or x is going to be equal to 2.6. And there will be a bound on this. I'm just looking for what the mark scheme says. It says accept answers in the range of 0.2 to 0.6. So we've got quite a big bound on that. And 2.4 to 2.8. Okay, and question 19. A factory is going to make 4 different car models, A, B, C, and D. 80 people are asked which of their 4 models they would be most likely to buy. This table shows information about the results. The factory is going to make 40,000 cars next year. Work out how many Model B cars the factory should make next year. So I would do, as a fraction, 15 out of 80 of them. So in effect, that's going to be the sum that I try to do. I would keep it nice and simple. I could simplify that, but I think it would be actually easier to simplify that. So it's going to be 15 times by 40 divided by 80 is a half, and then a half of 1,000 is 500. Sorry, 5,000. Yeah, 500. And then 15 times by 500. Well, 15 times by 5 is going to be 75 with 2 zeros. So 75,000. Okay, question 20. Rizwan writes down 3 numbers A, B, and C. The ratio of A to B is 1 to 3. The ratio of B to C is 6 to 5. Find the ratio of A to B to C. So if I put these ratios, this is about combining ratios, if I put them all kind of in the same format, A to B is 1 to 3. B to C is 6 to 5. 6 to 5, not 6 to 6. So to combine them, I need to adjust this ratio. I need to make them all 6. So really, I'm not changing the second ratio, I'm just doubling the first ratio. So it would be 2 to 6 to 5. Express A as a fraction of the total of all the 3 parts. So, missed my format in there. Express A, so that would be 2 out of the total number of parts, which would be 11, 12, 13. And then simplify if we can. I don't think we can though. So we've got 2 to 13. And then the final part, Emma writes down the numbers. Emma writes down the 3 numbers, M to N to P. Find the ratio of M to P. So again, a little bit like before, I'm going to go M to N to P. And then because they're given as kind of mini equations, I would need 2 lots of n to be equal to p. So we've got in effect 2 to 1 there. And then for this one, we've in effect got 5 to 1, because I would need 5 lots of p to be equal to n. If I combine them, then that would give me 10 to 5 to 1. So I've done it the wrong way around. That's 1. Yeah, so I've got my ratios the wrong way around. So n to m, I've got my letters the wrong way on both. We are looking at 1 to 2. For the other one, we've got it as p to n. So it would be 5 lots of p would be equal to 1 lot of n. Then when we combine them, we would have 1 to 2 to 10, which gives me the ratio of 1 to 10. There we go. Okay, and for question 21, then we're looking to solve. Again, we've got an inequality, so we would minus 3 from both sides. So that would give us 5x over 2 is greater than 15. We then times both sides by 2. 5x is greater than 30, and then divide by 5x is greater than 6. And then the factorise, so it's going to go into 2 brackets. Both starting with x, and we're looking for 2 numbers that multiply together to make 9, and add together to make 10. So only combination there has got to be 9 and 1. So x plus 9 and x plus 1. Okay. And question 22. So in some versions of this paper, this isn't as a power. And let's just re-add that there. Take it out from there. When we multiply, we add the powers. So we're going to have 2 to the power 3 to the power 2, which is going to give us, and then we multiply the powers. So it's going to be 2 to the power 6. Question 23. Here are 2 cubes, A and B. A has a mass of 81, B has a mass of 128. Work out the density of cube A to the density of cube B, giving your answer in the form A to B, where A and B are both integers. Okay, so so density is equal to mass divided by volume. So I need the volumes of both of them. I'm going to leave them in. So the mass of A is going to be equal. Sorry, the volume of A is going to be equal to 3 to the power 3, and then the volume of B is going to be equal to 4 to the power 3. I'm going to rewrite the masses here. 81 is actually 9 times 9, so it would be 3 to the power 4. 128 is going to be, so let's just, 128 is going to be 2 to the 64, which is 2 to the 32, which is 2 to the 16, which is 2 to the 8, which is, I feel like I've missed one, 2 to the 4, which is 2 to the 2, 2, 4, 8, 16, 32, 64, 128. So it is trying to be overly, 2, 4, 8, 16, 32, 64, 128. So it would be 2 to the power 7. And then 4 squared is going to be 2 squared times 3. So that would actually be 2 to the power 4. Keeping them in terms of their index form just makes this question a lot more straightforward. So the density of A, density is mass divided by volume, so the density of A to start with is going to be 3 to the power 4 divided by 3 to the power 3, which is just going to be 3. The density of B is going to be 2 to the power 7 divided by 2 to the power 4, which is just going to be 2 to the power 3. So our density is going to be 3 to the 2 to the power 3. So I think that's going to be 3 to the 8. No. I messed up there. That should have been 6. Which makes it just 2. That's just 2 to the power 3. 3 to 2. If you worked it out in terms of bigger numbers, it would simplify down exactly the same. I'm just suggesting that that would probably be a more straightforward way. And then question 24, this one was hated by students when it was sat. It was just difficult to visualize. So in effect, we have got rectangles, 3 identical rectangles, A, B, and C. Rectangle A has 5/8 shaded. Rectangle C has 9/11 shaded. Work out the fraction of shade B of rectangle B that is shaded. Arguably the most straightforward way of doing this is to say if that's the fraction that's shaded, then the unshaded would be equal to 3/8. If that's the fraction that's shaded, then for that one we've got unshaded would be 2/11. So for rectangle B, what we really want to do is 1 minus the amount that was unshaded on the 2. So I'm going to work out that fraction first of all. So it's going to be 1 minus, and then they need to go to the same denominator of 88. So I times the first one by 11, times the second one by 8, and then subtract them. Then add them. So it's going to be 1 minus 49 out of 88, which is going to be equal to 39. Yeah, 39 out of 88. And then we'll just finish off. This is a breakdown of all of the questions. This is actually the questions where they came from. And you've got the mean score per question, and then the average for the various grades. And they've given suggested grade boundaries. They've suggested if you can get around 53 marks on that paper, that would be a comfortable 5, which is quite low out of 80, but there we go. 25 for a 4, 14 for a 3, and so on. I hope you found that useful. I'll be putting out the paper 2 very shortly. Thank you for your time in watching, and subscribe if you like.